All right, so we are going to talk about the Pythagorean theorem. I don't know if my video looks a little slow, so I'm just going to turn it off. Okay, so, but you all can see the problem there. So what we want to do is, we want to find the third side here. So this side right here, we don't know that. So what we're going to do is we are going to use the Pythagorean theorem, which says that in a right triangle, a squared plus b squared equals c squared. And what exactly are a, b, and c? A and b are the base and the height. And you can make either one either. But why don't, I mean, if we want to, we could just always call b the base and a the height, but it really doesn't matter. It just matters that c is the longest side, which has a special name called the hypotenuse. Hypotenuse. Okay? So, first thing, label sides, correctly. So we'll call the 4a, the 1b, and the x is c. How do you know which side is the hypotenuse? It's because it's across from the right angle. So last week we talked about right angles in terms of area. This time it helps us find the hypotenuse. It's across from it. Okay, so now we're just going to substitute. Substitute. So that's going to look like this. So we know that a squared plus b squared equals c squared. But now we know a is 4, b is 1, and c is our variable. Then we're just going to use our order of operations. So we got to square the 4 and the 1. So that's 16. Then we're going to add the 16 and the 1 together. Now, do not divide by 2 to get rid of the square. Many people love to do that, but it's wrong. All right, because the inverse operation of this square is not dividing by 2. It is this thing. Do you remember that? You should have seen that in last week's interleaved assignment, the square root. We want to square root both sides. So the answer is the square root of 17. Let's see if that's here somewhere. Aha, there it is, square root of 17. Let's do another one. So we're gonna, now see, this is a good one here. This is a good one to do as well, because when I label the sides, so I see the right angle. The side across from it is C. All right, after that, let's just make one of them A, one of them B. Write the formula, and then substitute. 2.5 squared plus x squared equals 6.5 squared. And you can use get my calculator even. All right, I mean, not that I can't do it, but So it's 6.25, that's 2.5 squared, it's 6.25. Bring down the x squared. 6.5 squared is 42.25. All right, then what do we do? See, so now the variable is on the AB side. So what we got to do is we got to get our variable on the left where it is and our numbers on the right. Remember that? So we got to take this 6.25 and move it over there. How do we do that? Well, you can think of it and you can just move it over there like we did earlier in the year, or you can subtract both sides by 6.2. In any case, we end up with subtracting 42.25 minus 6.25, which is 36. And that we'll take the square root of both sides, and that is a perfect square, 6. So that's how you do that. That's the Pythagorean theorem. I think something that even people on the street will agree is important. Oh, it all is important. You know, they just don't all know about everything. Hey, Terry. What was that? All right, now this one is an isosceles triangle. That's crazy. We just did the angles and isosceles came after the angles. So the thing about the Pythagorean theorem is it works in right triangles. And so we need to find the right angle. So that is right here, okay? So the thing about an isosceles triangle is this line in the middle here splits the base in half. So we can think about it like this. Y and Y. You know, both those are the same. And then if you add the Y's together, it would be the X. Okay, so what we're going to do is we're going to just focus in on one of the halves, and we're going to use the Pythagorean theorem. So across from the right angle is our C, and then A can be the 8, and B will be our Y. Okay, so A squared plus B squared equals C squared. The square root of 80 squared, B is 8. And then A is that Y. All right, so then Y squared, 8 squared is 64. The square root of 80 squared is 80. And now we gotta put our numbers on the right. And what is 80 minus 64? 16. So now we square root both sides. And the answer is 4. But that's the answer for Y. So now our last step is over here. Don't forget that last step. Whoop, right, 16, it'll be 8. The answer is 8. Because when we solved for Y, we got half of it. So we had to just multiply by 2. All right, so that's that one. Now, the review assignment here is about the rules of exponents. So go ahead and try quiz 3 before you watch me do the answers here. So pause the video. Okay. All right. Hopefully you pause the video. Now I'm going to do the answers. So this guy, the square root of, negative 1/4 squared is negative 1/4 times negative 1/4. Negative 1 times negative 1 is 1. And 4 times 4 is 16. And that's all we got to do. Multiply the tops and multiply the bottoms. See? I was right. Okay, now this is the product rule. That says when we have the same base, the base in this case is the z, we add the exponents. If we saw a fraction, then we would subtract the exponents. And if we saw parentheses, we would multiply. I'm sure we'll see that in the quiz. So, oh, why did I just do that? Okay, scratch that. I was thinking about the other rule. All right, so we're going to add those exponents together. Negative 11 plus negative 15 is negative 26. So the answer is z to the negative 26. Z to the negative 26. All right. See, now here's the other rule that I was just thinking about. This is where we would multiply the two exponents right here. So 2 to the 4 times 2, which is 2 to the 8. So n equals 8 because they want to know that we'll n there. All right, so that would be 8. It's called the power to a power rule. And then here we are. We have a fraction, and that's when we use subtraction. But even though that's the rule, we kind of got to work backwards, don't we? So to use the rule, we would do x minus 3, and we would get the answer. But they gave us the answer in this case. They said it's 5. So now, we actually use our quotient rule to set up this little equation. So how do we solve that equation? We put our variables on the left and our numbers on the right, and we change the sign when we go over the line. So x equals 8. That was a one-step equation. All right. So what about this one? What is the sign of negative x to the third times 0 over y? Well, you see the 0 over y, that's going to be 0, because when you divide by 0, you get 0. And so that's going to make the whole thing 0. Select the equivalent expression. Okay. So this is using the power to a power rule. So we're going to take that 3 and multiply it by the 2, which makes 6. And 5 actually has a 1 that is just not written. So we're multiplying the 3 times that 1, which is 3. And so an equivalent expression would be right here. Power to a power rule. Okay. Now this is a negative exponent. So negative exponents are positive exponents when you write them in the other part of the fraction. And you might say, Mr. Field, there's no fraction there. Of course, you could make one. And then you rewrite this. You could rewrite this with the x to the negative 6 in the denominator. You just have to make it x to the positive 6. And so that is the equivalent expression. And the last one here, select the equivalent expression. So what rule are we going to use? Well, we're going to use the power to a power rule because we have those parentheses there. And then also we have some negative exponents. So we may need to move things from the denominator to the numerator, or the numerator to the denominator. So let's give it a try and see what happens. Well, now actually, I'm noticing that negative times a negative is a positive. So that all those negatives go away. So negative 9 times negative 7 is positive 63. And negative 9 times negative 2 is positive 18. Negatives go away. All right, and that's it. Look at that. And I think I leveled up 10 skills. All right, so go ahead, give all that a try, post in the organizer, and we'll see you on Thursday to go over all your questions.